Now that you've completed the ascending tracts, let's talk about the descending tracts. We will talk about the corticospinal tract. It's good to note that they give you directionality with these names. Cortical, telling you it's in the cortex of the brain, and spinal cord. So now we know it's a descending tract. The tract is responsible for motor function to the limb and trunks. The tract begins as an upper motor neuron in the motor cortex of the brain, or as we like to call it, the precentral gyrus, and descends to the midbrain, pons, and medulla. In the medulla, about 90% of the fibers cross over or decussate in the lower medulla, or the medullary pyramids. These fibers go on to descend laterally down the spinal cord and synapse with lower motor neuron fibers in the anterior horn of the spinal cord. Then, these low motor fibers then go on to innervate the muscles of the limb. But then what happens to the other remaining 10%? So 10% of these fibers would run almost the same path. They'll come down from the cortex through the midbrain, pons, and the medulla. However, they do not cross over or decussate in the medulla. These fibers go straight down anteriorly in the spinal cord to make up the anterior corticospinal tract. These fibers then decussate at the level in the spinal cord across the anterior white commissure and to the contralateral side of the anterior horn and synapse, just like the other one, with the lower motor neurons to muscles. The fibers of the anterior corticospinal tract innervates the trunk. However, the fibers of the lateral corticospinal tract innervates the limbs. So how does that look on a cross section? Let's try this out. All right, on the cross section, we'll try to mimic the same thing. Let's go the lateral corticospinal tract first, which comes down from the brain. And right now we can see we're in the medulla because we have our lovely pyramids here. So just a reminder, I'm going to write M for medulla. And then we know they come through the pyramids. Again, this is anterior. The pyramids are anteriorly. Then cross over. All right. So right here, right now, we know this is where the lateral corticospinal tract would descend. Then it will synapse here in the anterior horn of the spinal cord and synapse with the lower motor neuron that then innervates the muscles of the limbs. The anterior corticospinal tract, however, follows a similar route. However, as we just learned, they will descend all the way down ipsilaterally until the level of the spinal cord, where it then crosses the white commissure, this is the anterior corticospinal tract, and synapse in the anterior horn of the spinal cord. It then synapses with lower motor neurons and then go to muscles to innervate muscles. I hope this helps. I think it's very, very important to note where the decussection happens so that you're able to identify where the lesion could possibly be. For instance, if the lesion is above the dissection point in the medulla, it would cause a contralateral issue with motor function. I'm going to repeat this. If the lesion is found above dissection, so anywhere between the cortex to the dissection point in the medulla, anywhere along right here, it was going to cause a contralateral loss of motor function. If the lesion is within the spinal cord, for instance, at the level, thoracic level of the spinal cord, it will cause an ipsilateral loss of function in the limbs. This is all motor function. Also, be very, very aware about the difference between upper motor neuron and lower motor neurons. Lower motor neurons are found in the anterior horn of the spinal cord. Therefore, that fiber running from the cortex all the way down to that point is an upper motor neuron. Upper motor neuron loss causes what type of weakness?